Hello, I'm Andrew, and I'm here to explain a concept and a method to implement this concept. However, you can use your own method to apply the same concept. This is intended to help improve Google Firestore. The problem it tries to solve is it's difficult to make complex queries without losing too much performance in huge database. Documents are sorted to make it easy to find the matches only in the desired range without having to check every existing entry. The previous real-time database couldn't deal with multiple queries unless you used a field containing both values. Firestore can deal with it using the zigzag merge join. It works well for multiple equality comparisons, but you still have to use composite indexes when it comes to non-equality comparisons. A question that comes in mind is, why can't we sort it in the way we need when we have complex queries? The document, in our case mangas, would be in multiple places at the same time, which would not even work. But a better question would be, can't we sort it in the way we need when we have complex queries? My answer is yes, we can. It looks like we can't because we're looking at it in a two-dimensional way. But when we look at it in a three-dimensional way, we have a new perspective, giving us new possibilities. From this perspective, we can sort multiple fields without affecting the order of the authors or the documents. In code, it would look like this. But of course, we need to know to whom it belongs to. It could be done like this. Now, we only need to intersect the users. This is the method used to test it, but you can do it in any way you want. I tried it in the database I made from scratch with Dart and I had good results. If you're interested in the code, let me know. I'll polish it and publish it on GitHub. It's messy right now because it's a scratch and it's only for personal use. I separate the collections in two folders, owners and sorters. Owners are the normal documents you have with the values. Sorters contain values only needed for querying. Each field has its own folder. Each field's folder is divided in parts to keep the file small. The main file of the field is a list that holds the parts, containing their start value, how much values they hold, and an ID. Since the fields are separate, and we can only order fields by themselves, I save them in the right order, so you don't have to do it when querying. Inside the parts are two files, a list containing the values it holds, and a map. The key is the owner's value, and the value is the owner's ID. When querying, I only need to know in which part it is, get the values from the list, and the owners from the map. If I limit each part to 10,000, it would reduce a search between 100 million unique values to 10,000 parts, and I would only need to look at the parts including the results. When inserting it, I only need to find which part it fits in, and update or create a new entry with the owner's ID. If the part reached the limit of entries, I make another part, and divide the entries between the old and the new part. It only happens occasionally, not for each entry. That's it. I hope it helps. Feel free to use it and contact me on Twitter.